30, numbers 19 through 29 odd. Remember the first three, I want you to use the substitution method, and the last three, I want you to use the linear combination method, okay? So here we go, number 19, the substitution method. Okay, step one. Do you see a variable that's isolated? No. Step two, do you see a variable that has no coefficient? No, I do not. So really in this case, guys, you can pick any variable you want, and you want to isolate that variable. I'm just choosing x here because I feel like it, no other reason, okay? So 2x plus 2y equals -4. We're going to solve for x, okay? So bring the 2y over, make it a -2y, and you're left with 2x equals -4, -2y. Next, divide everything by 2. These cancel, leaving you with x. Negative over a positive is negative. 4 over 2 is 2. Negative over a positive is negative. Your 2's cancel, leaving you with y. So x equals 2 minus y. Now remember, you used this equation here, so now you must use the other equation, okay? 4x plus 4y equals -8. So where the x is, I'm going to substitute -2, -y. So 4 parentheses, -2, -y, positive 4y, -8. And now let's solve for 4, or for y. Multiply your 4 through, you get a -8 and a -4y, and the positive 4y equals -8. Simplify, your y's cancel, and you're left with -8 equals -8. So, yes or no, did your variables cancel out? Yes or no? Yes, they did. Yes. So you're either going to have no solution, or you're going to have all real numbers for your answer. Or we could also say infinite solutions. Okay? So here we go. My variables canceled out, and you're left with a true or a false statement. Well, it's true. -8 equals -8. So that means the answer is infinite solutions. That means, students, if you were to graph this line and this line on a coordinate plane, they would fall right on top of each other. Okay? In other words, these two equations would give you the exact same graphed line. Alright? Alright, substitution, here we go. Do you see a variable anywhere that's isolated? No. Next step, do you see a variable with no coefficient? Yes, right here. So that's the one you want to get by itself. So bring the 3x over, make it a positive 3x, and you're left with y equals 4 plus 3x. Okay? So we go to the other equation up here, and where the y is right here, we're going to substitute 4 plus 3x. Okay? So here we go. 15x, -5, parentheses, 4 plus 3x equals -20. Now take your -5, multiply it through, and you're left with -5 times positive 4, -20. -5 times positive 3, -15x equals -20. Now, continue simplifying this side. Positive 15x negative 15x. They cancel out, and you're left with negative 20 equals negative 20. Now, question. Did all of your variables cancel out? Yes, they did. Now, if you would have said no, they did not, then it is impossible to get no solution or infinite solution. You can only have no solution or infinite solutions when your variables cancel out. So my variables cancel out, yes. So I'm either going to have no solution or infinite solutions. Well, students, look at what you're left over with right here. Negative 20 equals negative 20. Is that a true or a false statement? True. So the answer is infinite solutions. Okay? Or if you wanted to, you can move the 20 over, make it a positive 20, and you're left with 0 equals 0. Either way, you get infinite solutions. Okay? 23, substitution. I don't see a variable isolated anywhere, but I do see a variable here with no coefficient. So I'm going to get y by itself, bring your 2x over, make it negative, and there you go. Y equals negative 1, negative 2x. So pick that up and put it in for y right there. Okay, so negative 6x, negative 3, parentheses, negative 1, negative 2x equals negative 15. Now, take your negative 3, multiply it through, and you end up with negative 6x, positive 3, positive 6x equals negative 15. Continue to simplify. Your negative 6x cancels with your positive 6x, and you're left with 3 equals negative 15. So, did your variables cancel out? Yes. So your answer is either no solution or infinite solutions. Well, what are you left over with here? Is that a true or a false statement? Well, it's false. 3 does not equal negative 15. So your answer is no solution. So, students, if you were to graph these two equations up here, you would see the two lines would be parallel. Okay? They would never intersect. That's why the answer is no solution. Okay? Alright, last three we're going to use linear combination. So, right now if we were to add these two equations together, we would get negative 3x, positive new y, and a negative 3. Okay? So, obviously, nothing cancels out. So, we're going to have to either eliminate our x's or our y's. Okay? And really, either one's fine. For me, I'm going to get rid of my x's. So I have a 3 here. If I multiply the top equation by 2, that'll give me a positive 6 here, which will cancel with my negative 6. So here we go. 2 times 3, 6x. 2 times negative 2, negative 4y. 2 times 3, positive 6. And your bottom equation stays the same. Negative 6x plus 4y equals negative 6. So we add, cancels, cancels, cancels. So, yes or no, did your variables cancel out? Yes. So our answer is either no solution or infinite solutions. Well, look at what you're left over with. 0 equals 0. Is that true or false? That's true. So your answer is infinite solutions. That means if you were to graph these two equations, the two lines would fall right on top of each other. Okay? Alright, moving on to number 27. Alright, here we go. Linear combination, okay? So we either have to get rid of our x's or our y's, okay? I'm going to go with the y's this time. I have a 4 here, so if I multiply the top by 3, that will give me a positive 12 up here, okay, right here, which will cancel with my negative 12. So here we go. 3 times negative x, negative 3x, 3 times 4, positive 4y, 3 times negative 20, negative 60. Alright? Your bottom equation does not change. So we'll bring that over, and actually, there should be a 12 here. 3 times 4 is 12y. Okay? So your bottom equation remains the same, which is 3x minus 12y equals 48. So let's add these together. X's cancel, y's cancel, and over here we have negative 12. Okay? So, did all of my variables cancel out? Yes. So I'm either going to have known solution for my answer or infinite solutions. Okay? Well, is this a true or a false statement? 0 equals negative. Well, that's false. So my answer is a no solution. Okay? Now, if I were to graph these two lines, they would be parallel. They would never intersect, and that's why the answer is no solution. Okay? Alright, last problem here. Okay, students, here we go. Last problem. Okay, linear combination. But you know what, guys? Before we start trying to use linear combination, I would, first of all, eliminate fractions. I would not want any fractions at all in this problem. Okay? Not sure why it's not working. Okay. Anyway, so in my top equation here, I have a denominator of 4 and 2. A common denominator for 4 and 2 is 4. So I'm going to multiply this entire equation up here by 4. Okay? 4 over 1 times 3 over 4. Your 4 is canceled, leaving you with 3x. Okay? 4 over 1 times 1 over 2. Your 2 would cancel into your 4 2 times. 2 times 1 is 2. So it would leave you with 2y. And then 4 times 10 is 40. Okay? Now down here, let's multiply everything by your denominator, which is 2. Alright? So 2 over 1 times 3 over 2. Your 2's cancel, leaving you with negative 3. Negative 3x. Alright? 2 times negative y would be negative 2y. And 2 times 4 is 8. Now, as you can tell, students, if we add these two equations together, everything cancels right away. So we're left with 0 equals 48. Alright? So, did all of my variables cancel out? Yes. So I either have infinite solutions or no solution for my answer. Okay? Well, is this a true or a false statement? 0 equals 48. That's false. So, my answer is no solution. In other words, if you were to graph these two lines, they would be parallel. Okay? Guys, I hope that this homework video has been a help to you. If you have any questions at all, don't hesitate to contact me.